Okay, I think we'll get going. So, we're all here. Lovely to see you all. Welcome to Science Education Research Seminar. Ian is now Professor of Science Education or Education in general?
Science Education only. Narrow.
No specialist. At the University of Lincoln, and he's worked with a number of people here as well as across the country. Became very famous for all of the work on practical work in science, and so all of our PGCE students will be very familiar with Ian's work. And he's going to talk about something that's a fallacy, which is always interesting for us, isn't it? So over to you, Ian. Thank you very much.
Okay, so first of all, thank you all for coming. When I give a talk or presentation, it tends to be fairly informal. If you'd like to ask any really pressing questions, just interrupt during the flow, that's fine. If not, we'll have time at the end, we can discuss things. I should say that this is an idea I've been thinking about with colleagues for a number of years, and I think it's fair to say that I tend to be in a very small minority who hold this view. And what I want to do today, I want to talk you through why I hold this view. I'll be interested in your views on this, and I think it's very important because certainly there's a lot of movement towards the idea of scientific literacy. Now, I want to start by making clear that my background, because I don't want you to think that I'm anti-science in any way at all. I'm not. My degree background is a degree in physics. I trained as a PGC secondary physics teacher and spent many years as a physics teacher. I became a head of department in a secondary school. I then moved off and I worked again. My area was science education with Robin Miller at York, and I've stayed in the area of science education now. So I'm very passionate about science. I suppose my issue now is I tend to like the idea of being slightly more critical and challenging. So what I'm going to do today is I'm going to start with something that Robin Miller made 2002, so almost 13 years ago. He made the claim there appears to be a broad consensus, both within the educational system and beyond, that all children should study science throughout the period of compulsory schooling. Now, if anyone wants, I'm happy to leave the PowerPoint on here, so if you want a copy, you can have it, and then that's fine by me. Now, that seems to be the sort of rhetoric that we hear all the time. Wherever you go, is anyone here as a teacher? Anyone background in teaching? Oh right, okay. Well, I was worrying that there would be teachers, lots of teachers here who would start to sort of ooh and hiss me as things go on. But it looks as if I might be saying too much. Okay, so it's the sort of thing that you hear. This when you go to conferences, wherever you go, you tend to get this thing that there's this rationale that we should all be having, all our children should be having science education. Now, the reason I got into doing my PhD, I don't know why some of you have done yours, but I was teaching in a secondary school, and I started to do an MA in education, to focus on science education. And what I was reading, everyone was telling me that what you really had to do, you had to get your students to do practical work. You picked up a science journal, you read it, do more practical work, your students will love science, they'll carry on doing it, and they'll learn so much. Well, I was doing so much practical work, and at the end of the year, I might have got 2 or 3 students who wanted to do it, and they tended to be ones who were quite theoretically minded and didn't really like the practical work. Now, if we go back to the consensus that Robin spoke about, I started to question. So I often take a critical view of the literature. And I started to think, well, a broad consensus both within the educational system and beyond, but whose views were sought? When you get these kind of things, and if you read the Times Higher or you read something on, in the Guardian, where it gives you these views, whose views are we talking about? Now, certainly in the educational system and beyond this. Now, this is where maybe it gets a little bit controversial. In a way, I tend to see this as preaching to the converted. We have to consider, I think, are we surprised that people are saying we should be teaching science if they've got a vested interest in science? Now, if I go in and see some of my I am still friends with them, we argue a lot, but lots of my friends are still teachers of science in schools, and they feel very passionately that science is very important, and rightly so. If you spend your life teaching physics or chemistry or biology, or some of you here maybe in maths or whatever other areas, you don't want to hear people saying that area isn't important. Now, those views are valid. We can all have our own personal views, but it doesn't surprise me then when you start looking at who are making the claims that we should all be teaching, that the majority of the people who make those claims tend to be, well, other than me, science educators, science teachers. Certainly if you speak to people at Wellcome, Gatsby and Nuffield, these are organisations that like to fund science education, they have a vested interest in science education and in scientific literacy. So they're not going to be the people who tell government it's not really a sensible thing to be investing time and money in. So I think what we have to do, we have to step back a little bit and say, okay, there's a lot of talk from Robin, broad consensus, but that consensus is essentially amongst a group of people who have a vested interest in science education. Now, we have to justify that consensus, and I think that it's often the problem with, certainly in teaching science, and those of you who are science teachers will know, many of your students will say, why do I need to know this? Why do I need to know about Ohm's law? Why do I need to know about titration? These kind of things. But functional scientific literacy is arguably less questionable. So what we're saying here is we're moving it away from saying, well, everyone needs to know content, to what you really need to know. You need to know this thing, and I'll talk about it in a minute. You've got to be functionally scientifically literate in order to engage with things in the world. And we'll look at the arguments that people make, and we'll begin to untease those. But there's a sense that scientific literacy is a justification for science education. Now, so maybe, this is, the thing that I believe, I think that scientific literacy now has become a bit of a fig leaf. It's something that when you go out and you go to presentations and people are saying, why should we invest more in science? The whole notion of scientific literacy is portrayed as being something which is important and a reason why we should be teaching compulsory science up to the age of 16. So what is scientific literacy? It's something that people still argue about, but the OECD, the PISA framework, defines scientific literacy as, and there's their definition, the ability to engage with science-related issues and with the ideas of science as a reflective citizen. So there's clearly something here which is suggesting that we expect people, as a result of what happens to them or what they learn at school, they will leave school, and remember, scientific literacy isn't just about what you do in school. Scientific literacy is all about developing the idea of a scientifically literate citizen. So it's something which goes on essentially throughout your life. So we're expecting citizens to engage with science-related issues. Again, we're not quite sure what science-related issues are. We can talk about that later. And with the ideas as a reflective citizen. So we're expecting citizens that if you stop them out in the road and you ask them questions, obviously science will be part of the way they think about the world. Right, so this is what's suggested, and I think it's important to go through this. So a scientifically literate person, because remember, I suppose the title of this is that I don't think scientific literacy in a meaningful sense is achievable. So I think it's important to step back and say why I don't think it's achievable. And the scientific literate person in the literature is one who has the capacity, and this is what they're saying. So explain phenomena scientifically. Recognise, offer and evaluate explanations for a range of natural and technological phenomena. evaluate and design scientific inquiry and describe and appraise scientific investigations and propose ways of addressing questions scientifically, interpret data and evidence scientifically, analyse and evaluate data, claims and arguments in a variety of representations, and draw appropriate scientific conclusions. Now, I don't know how many of you have ever been into a school in the UK where we're trying to teach science, where 80% of the students would really not like to be in Key Stage 4 science lessons. The turnover amongst science teachers is higher than most other subjects. Part of the reason is science teachers are very unsatisfied people because they spend 80% of their teaching time teaching people who don't want to be in their lessons. Now, if you're trying to teach this, you've got to start saying realistically, are these aims achievable? And we're not just talking about, and this is where scientific literacy, in the sense that it's envisaged, widespread, functional, we've got to say the average student in the UK today ceases studying science at 16 with an average C grade. So what we've got to say is these things, to be widespread in our citizens, amongst the citizens of the UK, have to be achievable by those type of students. And that's the important thing to bear in mind. If we want this, this is what we've got to buy into. Right. So, explain phenomena scientifically, recognise, offer and evaluate for a range of natural. Now, if you delve into the literature and you start saying, well, okay, you know, people have got the, what phenomena do we want them to be able to explain? What depth of evaluation and how broad a range? And that, at the moment, is something that is very much not really discussed. Now, I've come up with a few examples, which I want to go through with you. The reason I do this is because I've got a PhD student at the moment. He's just finished, actually. He was looking at misconceptions and spontaneous reasoning, how people reason when given a novel situation. Now, surely you would say, if we all sort of exist in the world and we're used to the idea of summer and winter, it seems reasonable to say that something as fundamental as summer and winter, we should expect a scientifically literate person to be able to say, well, you know, why is it hotter in the summer and colder in the winter? Now, if we don't think that that is something that a scientifically literate person should be able to do, then I think we have to step back and start saying, well, okay, what do we mean by scientific literacy? So a very common feature for most of us, average lifespan 75, we're going to see 75 summers and winters. Can we have an answer? Well, the interesting thing is, you know what, most people, and this is data that's been collected, we've looked at, most people today, if you ask them, why do you think we have summer and winter? And this is after we've had national curriculum since '87. What do you think most people will tell you why we have summer and winter? What causes the average temperature difference?
Distance from the sun?
Yeah, they actually believe that the Earth moves much, much closer to the sun. And what Nick Voter, who's just found, is that the reason for that is most people, believe it or not, haven't really even thought about it. And when you ask them something, spontaneously they reason drawing on analogy. And if you're sort of standing in a room and there's a fire over there, you get warmer when you get nearer, you get colder when you go away, so that's why we have summer and winter. So, the question we then have to ask ourselves is, what kind of depth of explanation do we expect from someone who's scientifically literate? Now, if we start to talk about the tilt of the Earth, okay, we really need that, but we've also got not drawn to scale. Now, I arrived a little bit earlier, and it was interesting because I was speaking to Sharon about a trip down I had on the train, and if any of you get a copy of the Metro today, in the Metro they're talking about a near miss from this asteroid. Well, I'll show people if you want afterwards. And I was sitting on the table and there was a mother and a child there, and I was reading this, snickering away, thinking, well, here's an example of scientific literacy. And the lady said to me, oh, what's funny in the paper? And I said, well, just as a matter of interest, a bit of research on the side, it says that this asteroid is going to pass within 2.8 million miles of the Earth. I said, do you happen to know, a rough idea of 2.8 million miles? And she said, well, it's a long way, she said, but I couldn't tell you how far it is. It's no concept of it. So one of the things we then have to start thinking, well, lady on a train, citizen of the UK, been through the UK educational system, really had no idea of the scale of distances. So not only have we got things like this, where we've got the Earth about the same size as the Sun, we're worrying about which way we're putting the Earth rotating, but, is that something they're really going to worry about? So what depth of explanation? Now, this is where I become very sceptical then, because should they know that seasons on the Earth depend upon its rotation and the Earth's tilt, that the average planetary temperature depends on average distance from the Sun, and so on. Now, where do we draw the line? Now, I think part of the problem with scientific literacy is at the moment we are pushing much too far down this list of what we expect people to be able to understand, and that then becomes unrealistic. It becomes, in my mind, the achievement of it is a hope which we can't. Now, does it matter? I don't think it does. Now, I did say to you in the beginning, I am a scientist, I love my subject, but I wouldn't want to think that I felt that having a scientific perspective of things was necessarily something that if you didn't have it, you wouldn't live a full life. I've got lots of friends who engage in lots of interesting things. They could be a justice of the peace, they do lots of charity work, they vote in elections. If you try and find definitions of whether they're engaged with society, they are. But if I was to ask them why it's warmer in summer than the winter, they'll tell me, well, we're obviously nearer to the sun. It's this foregone conclusion. So I don't think there's really a reason why we have to worry too much if people don't know these things. I mean, we can all have a little laugh and, think, well, isn't it funny that people don't understand that? But I mean, if you were to say to me, who was the 6th King of England, I haven't the foggiest. Or if you ask me, which was Beethoven's 3rd Sonata, I haven't the foggiest. It doesn't mean I don't enjoy certain things in life. I just don't think we need to be overly worried. Now, here's a simple one for you. What about very simple phenomena? I mean, any of you primary school background? Right, I mean, if you go to primary schools where they're talking about the importance of teaching science, they love getting the magnets out. The kids take the magnets and they find after a while, learning by discovery, that north and north pushes together, okay? Do we think that people should be able to explain that? No? What's the point of getting the kids to actually push two magnets together if we don't want any explanation of that? Now, has anyone seen the brilliant Feynman lectures on magnetism? If you haven't, I strongly recommend you invest the time. I mean, if you haven't got this, if you just type in Feynman lectures on magnetism, it comes up. It's an absolutely brilliant clip, and it shows you perfectly well I think it does anyway, the fallacy of scientific literacy. Because there you've got Feynman, Nobel laureate, and the chap says to him, I've got a question for you. And Feynman says, what question have you got? And he says, when you get these two magnets and you sort of bring them together and you feel this kind of pushing force, and Feynman says, I know what you're saying. He says, but what's your question? And he says, well, why? And it seems to me that, scientific literacy, and what, if you watch it, I won't spoil it for you, Feynman's answer is that all that can be explained to non-physicists, and by non-physicists he's talking about people with a degree in physics, is essentially because that's what light poles do. Now, if that's what we're saying is really achievable by scientific literacy, do we really need to worry too much about the depth that we're going to? Does it matter if you can't go further than that? Now, I don't think it does. So, Why the need for scientific literacy? Okay. Those of you who have heard of scientific literacy will probably have heard of these oft-stated famous five. Thomas and Durant in '87 came up with 5 reasons why students should be scientifically literate. In a way, if I hadn't shown you that, and I'd asked you to sit down as a group and come up with a justification for the country spending so much money on science education, you would probably have come up with a list which was very similar to this list. It seems to me that you could probably make the same sort of arguments, by and large, maybe about history or geography or MFL, but these are the ones which are often pulled out for science. So we've got the economic argument, you know, scientific literacy, positively correlated to a nation's wealth. I learned the other day, apparently, so is water consumption. Yep. So, you know, if we all drink more water, we're going to drink ourselves out of our economic woes. So it's, you know, you can find correlations, but whether they're causal or not, that's a different issue. The utility argument, people would argue that, you know, being scientific literate is really important because it's useful. Now, we've got here, which is probably going to not work very well because I'm standing too far that way, we've got a sort of a video capture and we've got a computer. And before I came in here, I sent a text to Mary, and I don't know how they happen. I know if I write a traditional letter and put it in my letterbox, how it gets to the person I send it to. But if you ask me, if I send you an email, how does that work? I haven't the foggiest. And I would say that I think we don't, I mean, part of the fallacy here is I don't think we do live in a scientific society. I think we live in a technological society. And a technological society is very, very successful because technology is designed specifically to enable people who don't understand science to buy the product and use it. So I don't think we really do that. I think, well, we'll go through these. But the democratic argument, required to participate in decision making, I'll go to that later, I don't think that holds water. Social argument, again, required to link science to the wider society. Again, we will take that. That's the only one I think is a very strong argument. The cultural argument, it's a major achievement of Western culture. It is. I'm very passionate about physics, science in general, and I do think as our cultural heritage, it's important that people are introduced to that. Where I would begin to argue is, well, how long do we have to ensure that people study science to appreciate that? Certainly up until the age of 14, but do we need to keep sort of, you know, harping on about science until 16? That will come to. So,
can I ask you a question?
Yeah, sure.
Do you think little green pixies picked up the pixels from your phone and delivered them on
No.
your nose?
No.
So you know the point I'm trying to make?
Yeah, no, and I think it is a good point, Sharon.
Does it allow you to rule out explanations, even if you can't understand the correct?
Well, that's the interesting question, because the issue could be, and this is where I once came to Nottingham, this is many years ago, with a group of PGC trainees, and there was a talk that was put on about, it was the pros and the cons of GM food. And there were 2 very eminent speakers on both sides, and we sat there and we listened, and we had someone, I think it was from Monsanto, telling us that GM food was absolutely fantastic. And I could just imagine ringing up and saying to my wife, it's okay, don't throw any of it away, feed the kids, brilliant. And then we had someone like that, it must have been for some organisation like Greenpeace on the other side, and I listened and thought, oh my gosh! And he'd ring up and said, no, don't feed the kids that, throw it out. Now, afterwards, we started to discuss, well, what is the informed decision? And what I'm going to argue is, in order to make an informed scientific decision, your level of conceptual understanding has to be much, much higher than the equivalent of a C grade at GCSE. So, if you're saying to me, do I know it's not green pixies? Yeah, and I can say, well, so my answer to that is, I can do that because I've got a degree in physics and have studied physics at a higher level. Now, most people stop believing in pixies for a variety of reasons, like they stop believing in Father Christmas, and so they probably, if you said to them, well, actually, they're carried by these little green pixies, they would laugh at you. If you started to say to them, well, actually, can you explain how it happens? Most people, I would bet a large sum of my salary on, don't know, don't need to know. They would laugh off Father Christmas, they would laugh off pixies. They would probably say it's something like it's electricity going down a wire. They would use that. Now, if you probed a little bit deeper and asked them, well, what's electricity? They probably wouldn't know very much about that either. So they use words which they've heard in the context of technology, very little else. So they can rule some things out. And what I would like to do, we'll come to that, is I would like people to have an understanding of things which are important in their everyday lives. So I would like a bottom-up approach, rather than eminent science educators saying everyone should know A, B, C, and D. I would like to go out and see how do people use science in their everyday lives, what's important for them, and then to make sure that what they do actually use in their everyday lives is what we teach in terms of scientific literacy. But no, I do want people to be able to make reasonable choices, but I want to recognise that we've got to be realistic about what we can achieve, and I think that's the important thing. Okay, so the economic argument. She's not leaving because she disagrees with me.
She's got to find the green man.
Yes, you've got to find the green man, that's right, yes. Right, the economic argument. So, again, industry does require, you know, I have said, I do want to be open, I do feel that science is a very, very important area. And industry does require highly qualified scientists. But I've been working in teacher education now for 8 years, and I do know that lots of the people who come to study to be chemistry teachers, and certainly biology teachers, are often very highly qualified with PhDs in chemistry, biology, less so in physics, to be fair, there's such a shortage, and they come to train to be teachers because there isn't any work out there in industry for them. They can't get full-time positions, they go on different kinds of contracts, and they want to get a mortgage and settle down. So the economic argument seems to be one which is generated by people in industry who want to keep a large pool of labour out there, skilled labour that they can draw on.
But what we need is technicians, not...
We do, yes, you see, yeah.
But technicians is more than just
Yes.
SEC, I think.
Well, I would agree with you, and I think there needs to be a pathway to that, definitely. But that's not the same pathway towards. So, for instance, we did a study that was working with the Sand Hutton Research Centre, which is the government centre for farming and fisheries just outside York. And they've started up a training programme where people who want to be technicians can go there and they get their qualification, and I think that's a fantastic way forward. So they work there, they get their qualification, they've got a job. I think the worst thing for me, having been a physics teacher, is where we require people to carry on studying physics to GCSE because we think it's good for them, and they finish up with, let's say, a D grade, which has got no value for them or for anyone outside, really. So yeah, I definitely agree with that. But what evidence is there in industry requires, and what I will say to you is that, I'll come back to that. Yeah, these are the questions. But yes, I definitely agree with the point you made. As I said, technology is designed for scientifically illiterate people. That's why it's so fantastically successful. You know, I said to my wife, I wouldn't mention her by name, but you know, she loves using her iPad and a mobile phone and all these things. She hasn't the foggiest about anything to do with science, and she doesn't need to. And that's why it's successful. But we do need people who can develop that kind of technology. We do need science for future scientists, and we do need qualified technicians who can work in that intermediary phase between the scientists and the citizens. But my argument is I don't think citizens need to know how technology works. They don't need to have an understanding of the underlying science. It can be used very effectively without that. Okay. I don't think the democratic argument holds at all. Many people, and okay, anecdotally, but certainly I don't think there is any study that has been undertaken which shows that there is a correlation with engagement. Most people make decisions about whether they should have a wind turbine in their back garden, not on the basis of their understanding of CO2, global warming, but simply on the fact that if there's a wind turbine in their backyard, it will push the price of their property down, and they don't want it there. So lots of the people, I mean, you know, the NIMBY, not in my backyard, we call it NIMBY. So you get lots of very intelligent people who might think, well, actually, from a global perspective, maybe it is a good idea to have wind turbines, but hang on, I don't want it there. I think I have to be careful about speaking about colleagues in a conference later, but there's a really nice example. Social argument, we do not need to link science to the wider society as science engages, and this is what I say, with technology. If anything, we need to engage society with technologists, people who actually do the things which are necessary for us to function. But, you know, I mean, we've got 3 children, none of them have wanted to study science. Probably down to me, actually, thinking about it. I suddenly thought, gosh, that's pretty bad, isn't it? Maybe I'd put them off science. So I don't think that argument holds, which really leads us, as I think, the strongest one. I really do, as I've said earlier, think that the cultural argument is really important. But I do think it could be taught effectively by the end of Key Stage 3. Key Stage 3 in the UK is up to the age of 14, after which subjects like history, geography, music and art, students can drop them. You don't have to study those subjects after Key Stage 3. And I think that we could teach good scientific literacy if it, as I'll say and I'll come on to, if it's directed properly by that age. And I think that's what I will be suggesting is achievable scientific literacy. Okay. If you want to read an interesting book, which isn't actually referenced very often, which is not really surprising, it was undertaken by Shamos, and he wrote The Myth of Scientific Literacy, and you'll see my play on the fallacy is derived from that. When I came across this book, I thought, wow, this is really interesting. His work has actually focused very much on the economic argument. And he has shown, I think quite conclusively, that there is very little evidence to show that scientific literacy has got a link to the national economy. At best it's tenuous, and worse, he argues, it's fundamentally flawed. You can pick the book up. For some reason it's not cited very often, and you can pick it up on Amazon for, I think, 1p. It's a good investment for a penny, if ever there was one. Okay. Now, what do we mean by meaningful, widespread scientific literacy? I think my own work has shown me that people often talk about things in a way without thinking what the actual word means. So if I look at the research that I've done in terms of practical work, people will tell you that practical work motivates. And you can go into schools and teachers will tell you, I'm doing a lot of practice. It really motivates the kids. And then you begin to unpick what they mean by that. And what they actually mean by motivate is more about situational interest than real motivation in the psychological sense. So when we're talking about meaningful, widespread scientific literacy, I think we've got to say, well, okay, what are proponents of this really wanting? And it seems that if something has meaning, synonyms are relevant, significant, material, important, consequential, valuable, and you can come up with things of your own. So we're thinking about a scientific literacy which has, if you like, I like relevance to people. And I think by relevance it means that people will be using it in their everyday lives. Now, I asked a number of people if when they bought their mobile phones, did they look at the radiation output per square metre on their phones when they bought it. And they said no, they bought it on the colour of the packaging or other things which, you know, is what we'd all expect. Now, it raises questions then about how things are perceived. So, a use and value in terms of understanding the world we live, conceptual science. So I make a distinction here between conceptual scientific literacy and functional scientific literacy. And I'm going to argue I think that distinction is important. Conceptual scientific literacy, those of you who've heard about the idea of the big ideas in science. Big ideas in science, one of them would be that, you know, matter is made of these little building blocks called atoms. And that's a conceptual idea. And I think part of scientific literacy has a role in helping people understand these basic ideas. And also, there's another type, and this is the functional scientific literacy. And this ties in with the thing that Sharon was talking about how we make certain decisions using scientific literacy. So I think when we look about it, we have to keep in mind that there is two separate components. And what I will argue is I think that this is achievable to a limited extent. This can be achieved, but if we want this to be widespread, the associated level of conceptual understanding is far beyond what can be achieved for the average citizen. Okay, so there we've got, I think, to provide and now, what I'm beginning to do, you'll notice, I'm introducing terms which I think now make things more achievable for the average citizen. So the average citizen does not like quantitative data. So the mathematicians amongst you here, you won't be surprised to know that the reason most people will tell you that they don't want to do physics is because there's too much maths in it. And that's why when we try to expand, I suppose, the number of people coming in to do physics, we moved away from a very mathematically quantitative, and we introduced different modules like, what was the one that I was in? It was one on sort of safety, all aspects of, you know, driving and things like this. Things which could take things to a more qualitative perspective. So I'm saying that meaningful conceptual scientific literacy should enable a qualitative account. So I want people to be able to talk about things, not necessarily to be able to do the quantitative understanding that maybe scientists would do. So a qualitative, and I've given, you know, I would hope that people could tell us why it's colder in the winter than the summer. I mean, there's some lovely videos. Where does the stuff that makes plants come from? Have anyone seen the work that was done? I think it was at Berkeley, California. They took these people who were graduating with their degrees from a really eminent university, and they stood there with a lump of wood in front of them, and they said, you know, where's the stuff in this wood come from? And they said, well, it's wood. And again, if you just search under Berkeley wooding, you'll find, so you've got these people, they've got all their mortarboards on, educated people, and they say, where do you think they tell you the wood comes from? Where does it actually come from? Where do you think?
Out of the soil.
Yeah, most people believe that, and it makes sense because obviously you put your compost on your vegetable patch because you want your plants to grow. And that's why things don't grow well other than the water well in the desert, because, you know, there's nothing for them to suck up through the roots. So I think, you know, we want people to at least know some basic things, but qualitatively. And why do people, I always used to like covering biology lessons, people would ask, you know, these are sort of questions that people often want to know the answers to. They don't want to know about Ohm's law, they don't want to know about Neptune, but, you know, why do we get goosebumps? Or, you know, the other one that they love is, you know, why do men have nipples? And you think, oh, that's an interesting question. They want to know things like that. And I think part of a basic scientific literacy has to deal with those. So here, this is conceptual scientific literacy, and I suggest, realistically, it must be, if we want our citizens to have this, it must be achievable by the majority of C+ GCSE grade students. And so I'm saying it needs to relate only to a very basic qualitative account of a narrow range of issues. So although physics teachers would love to teach everything because they're passionate about their subject, and the same for chemistry teachers, and you know, if you sit down with a group of, and we had 2 weeks ago a focus group with physics teachers, and we said, if you had to cut away half of the syllabus, what would you cut away? And they said, you can't. It's been pared down so much, there's nothing left in it. But interestingly, when you then go out and you bring people in and you stop for people in supermarkets and post offices, and you say, well, what do you remember of your physics or your chemistry education? The sort of things, the only things they remember being hooked up to the Van de Graaff generator, hair standing on end. They remember the thermite reaction, and they remember some dissections of eyeballs or hearts or whatever they did at the time it was allowed. So they've got that, you know, the wow factors, but very little else. So although the physics teachers and chemistry teachers want to get as much in as possible, the only people who tend to recollect that are the people who go on to study science at a much higher level, not the people that the argument for scientific literacy is essentially being designed for. Okay. Now, I went to a conference, the ASIRA conference in France, and I was standing outside this conference hall with a colleague talking about scientific literacy. And we were looking into this hall of science educators. And the really interesting thing was they were all sitting down for lunch. And they were cramming so much food in their faces, and many of them were sort of, you know, had clearly eaten far too much. That we started to, and this is where I suppose we started to think about this. Now, here's an example that we developed to this. It makes sense, well, at least I would think it does, you know, feel free to question this, that a scientifically literate person, and remember, a lot of work on scientific literacy now in secondary schools in the UK is focusing on healthy lifestyle. You know, you shouldn't be smoking too much, you should be doing exercise, a balanced diet, whatever it might be. So a scientifically literate person, we would arguably understand that fatty cuts of beef, often those used in the manufacture of cheap burgers, contain a large proportion of saturated fat, which can increase blood cholesterol levels and as a consequence the risk of cardiovascular disease. And yet, they still choose to eat this on a regular basis because they like the taste. Now, just because you're scientifically literate doesn't necessarily mean that you have to make all your decisions on the basis of scientific things that you know. Fine. But the question we then have to say is, how often do we actually make any decisions on the basis of scientific evidence? I mean, what sort of things? I mean, when you buy new cars for your tyres, do you actually go out and find the coefficient of friction? You know, what sort of examples do we use where we actually use the knowledge which is, I suppose, available to us? Now, this is why I suppose I think things are unachievable. The problem is essentially that in order to achieve what I think is a meaningful functional scientific literacy, there has to be a corresponding widespread conceptual understanding. If you don't have that, as I gave the example with whether or not you should eat genetically modified food, you can't engage in that realistic scientific discussion internally. You can't be sort of reflective because you just don't have that level of knowledge. Now, one way to think about it, and we tried this a couple of months ago in a school about, was it a good idea to build wind farms or not? Now, to be fair, in a good way, most of the kids said straight away yes. And then we said to them, why? And they said, well, global warming. So they had this idea that wind farms were a response to global warming. But when we started to ask them what did they know about the manufacture of concrete, they knew nothing about concrete. They had no idea of the concept of embedded CO2. Now, the evidence does show that the amount of embedded CO2 in a wind turbine is less then it will save it offsetting against fossil fuel burning. But they weren't making that decision based on that information. They didn't have access to that. So really, although they were saying yes to wind turbines, it wasn't a thought through justification. So in order to make that kind of decision, it's a bit like, you know, when there was the MMR vaccination. So the government, you're familiar with that, you know, we have the MMR vaccinations, and there was a GP, I believe, who published some, they said, spurious results which showed that there was a link with autism and the MMR. And of course, everyone panicked and stopped taking the kids down to be vaccinated. And then the government came up with a counter-argument. But basically, it wasn't that people were making an informed judgment. They were just basically, well, this is what we're being told. But the level of understanding that you would have needed to engage with that at an appropriate level, to understand the risks, is again something most people don't have an understanding of what a probability is. Now, without an understanding of probability, how on earth can you begin to even talk about weighing up risks? And this is part of, I think, the issue that we've got. I'll skip this at the moment because I'm conscious of the time. This is just going through. These are arguments that you can find for growing and consuming GM-modified food. Likewise, there are arguments against that. Now, if you take someone whose level of conceptual understanding is very low, although they might be able to remember some of these things, there's no way that they can actually engage with them at a conceptual level because they probably won't even know some of the meanings of the words. But they can't actually relate one to the other and try and question what the risk factor is because they've got no understanding of maths. So the idea of, well, if we do this, the risk is, means nothing to them. Okay, now, is it realistically to believe that you could hope that the average citizen could make a scientifically supported decision about whether we should grow GM crops and whether they should eat them? And I, at the moment, find that very hard to, well, I find it difficult to think it can be achieved. I think there's a lot of people out there who will say to you, yes, we do, and no, we don't. I mean, I don't eat GM food, but if you asked me how GM food was produced, I couldn't tell you. If you could ask me the process by which it's actually modified, I don't know. If you ask me what the risk is, I don't honestly know. The reason I don't eat it, as I said, is because my non-scientific wife won't have it in the house. That's it, end of story. So, in a way, I think that's how most people make their decisions. Now, if most people like eating, let's say, McDonald's, and McDonald's contain GM-modified soy product, they will carry on eating it. And that's, I think, the sort of way that, you know, scientific literacy isn't really making any difference at all. If we're looking about collecting evidence, I think what we need to do, as I've said, is we need to start saying, well, what ideas, what conceptual ideas does the average citizen have a real interest in knowing? And what functional scientific literacy people actually use in their daily lives? As far as I'm aware, that hasn't happened yet. We haven't actually gone out. No one's carried out any studies in science education or education to actually go out into the, you know, into the world around us and actually see what scientific literacy people are actually using. And I think that's the first step we should do. I think it would be very useful to know what. And again, I suppose I know there's people in here from maths. What kind of maths do people actually use in their everyday lives? Do they use algebra? Do they use trigonometry? I mean, what is mathematical literacy as well? You know, these are areas which I think correlate very, very strongly with this, and it'd be interesting to hear from those here. So I would like to design a curriculum that can be delivered in its entirety by the end of Key Stage 3 at a level that's commensurate with a student of average academic ability. What I would like them to do is move to a system of optional biology, chemistry and physics for Key Stage 4 that are academically rigorous and are designed for future scientists, because I do think we need future scientists for the reason that people have argued that we need scientific literacy. The main argument that I think Shamos makes, and I think is, as we hear continually there's a shortage of scientists, then let market forces drive up the currently low pay scientists get. If there's a financial incentive, you know, if you were saying, well, if you're an industrial chemist, you'll earn as much as if you were a merchant banker, we'd probably find lots of people wanting to be industrial chemists. Recognise, and this I think is an important thing, we need to recognise that we do need highly trained scientists and technologists, but most people can live their lives as happy, engaged citizens without the need for that much scientific literacy. And I think we have to accept that. However much we might not like that, I think it is important. Now, what I'm going to present to you now, just the last few slides, I think it's all about realistic expectations. I'm not advocating there's no need for scientific literacy. What I am saying is we've got to be very careful about what scientific literacy means, and I want it to be achievable by most people. That's what widespread scientific literacy is about. We're an atypical group. You're sitting in a Russell Group university, you've all got very good academic qualifications, and so you will have a better understanding. So when Sharon said, you know, do we think there were little green pixies taking messages? We all are. Of course not. But we have to recognise that we're atypical of the population. So what I would like people to be able to explain some phenomena scientifically. Recognise, offer and evaluate of a limited range of natural, and this is going back to the things that they need in their lives, finding out what they want and helping them to do, to understand. I would like them to evaluate in some very basic scientific inquiry and appraise a small number. So it's not the idea that we're going to get everyone to understand everything. So as you can see, I've taken the statements which came out of the earlier definition, and I've transformed them in a way that I think can make them achievable. And again, you'll see it's moving more to a qualitative approach. Interpret very basic data and qualitative evidence, not in a scientific way. People aren't going to be scientists. People don't sort of go out and we collected some data. We wanted to find out about misconceptions, and we've just published actually a comparative study that looked at the difference between Chinese undergraduates in the UK and UK undergraduates. Chinese students had stopped studying their science at 15, the end of compulsion, UK at 16. And we gave them the same misconceptions. And what we found was that the Chinese students had a statistically significantly lower level of misconceptions than the UK students. Really interesting. One example was, and a master's student of mine wanted to find out in the UK if people thought a big tin of beans or a little tin of beans would fall fast, you know. And 90% of Chinese students, when asked, said they hit the ground at the same time. And when we said to them, why? They said, well, it's Galileo's experiment. We're taught that specifically. So you had all these Chinese students saying that. UK students aren't specifically taught Galileo's experiment. So 90% of UK students, university undergraduates who stopped studying science at the age of 16, but still intelligent people, 90% of them thought that the big tin would hit ground because it was heavier. Now, we're talking, but we've been teaching for scientific literacy now for quite a few years. So what we're finding is it's just not working. We're getting people who are stopping studying science at the age of 16, intelligent people coming to university to study history, whatever it might be, but they've met the university entry requirements. We collected data from 2 Russell Group universities in the UK, and we were finding this still an enormously high level of misconception. So it's not working. So what we were thinking, and this is what's informing our decisions at the moment, is that we've got to be more realistic. What we really want people to talk about is qualitative evidence, an informed man. We're not going to make them into little scientists. So that's the end. Some people have said to me, but that's not a very positive way forward for science. I disagree. I think it is a very positive way. I think what we've got to do is we've got to recognise some people want to study science and will study science. Brilliant. Other people won't. I didn't want to study French when I was at school. And I think that what I'm really arguing or suggesting to you is that if we want a certain level of scientific literacy, it's got to be achievable, and to be achievable, we've got to recognise what can be achieved by those people who don't really like science. And we've got to look and say, well, what decisions are people making? And if we do that, then I think we can achieve a functional level, but it will be a very low level of functional scientific literacy. So I hope that's made you question, not necessarily agree, but hopefully to question. And if questions, by all means, yeah.
Do you think this inherent problem we've got with scientific literacy has something to do with the way students are taught and examined at school? Like you said, with the whole autism vaccine disaster, people just accepted that that was an issue because they were told that that was an issue. And because of the way that students are assessed, it's very memory-based. This is the information you need to know, this is the information you need to write in an exam. If it was more of a question-based education, do you think that would necessarily lead us to the situation we're currently in?
I think you've got a number of issues there. Firstly, I think that the reason scientific literacy has taken off and grown as it has done is because the idea of teaching content is perceived as being very difficult. And rather than trying to deal with that difficulty, and we have been trying, we've shifted the goalposts and said, well, if we can't get everyone to do a traditional Ohm's law calculation, let's get them to talk about nuclear power stations. And so you go into schools, and an interesting finding has been, as an example, that if you look at 21st century science, which is effectively has a large component of scientific literacy in, girls really like it. They like talking about the ideas. Now, I suppose part of the problem is I think it's good to talk about ideas, but if you don't have that content, that conceptual understanding, all you're really doing is just, giving your personal view. There's nothing wrong with it. I think it's important we all have it, but then that's not what scientific literacy is about. Now, I would tend to think that it's very useful for people to learn some things almost by rote. So when I was at school, I was terrified of maths because my primary teacher used to line us up around the wall, and we used to have to do the times tables, and we used to just read. She would ask you 7, 8, horrible 7 times tables. Now, when our kids were learning, we taught them their times tables by rote, and they weren't afraid of maths. Now, that doesn't mean that I hope that they would just learn them by rote and then not pursue maths further. No, it didn't. But I think you have to master a certain level of knowledge. I mean, if you look in terms of Kuhn's paradigms, there's the language that we all speak in a certain paradigm. There are certain things that mathematicians do, certain things that scientists do, that if you want to really work within that paradigm, you have to learn the rules. And there are certain rules in science that you need to learn. Now, and that's why science is difficult. There are more rules to learn in science than there are in history. So if you're comparing the level of difficulty, and again, research has shown that if you ask kids to rank different subjects, science is often rated as a difficult subject, so is maths, whereas things like English and history, the ones which have fewer rules to master, are perceived as easier. Now, most...
English has loads of rules.
Well, it does, but most people don't worry too much about the rules. That's why.
The rules. You have plenty of rules.
those rules aren't taught though, not as a body of knowledge. I mean, there are. I mean, you take most. I mean, again, if you mark undergraduate work or even graduate work, most people have got no idea about the use of an apostrophe, a comma, a colon. The structure of the language is not something that people have to focus on.
Sure, but it does have rules.
Okay, except it has rules, but those rules aren't taught as part of the body that the student. If you ask students which they find more difficult, physics or English, they'll tell you English, and they'll say the reason is they
some people might. I mean, I suspect people would, if you ask them about writing, they might say that was more difficult.
Yeah, I mean, that's interesting. I mean, I think that certainly the research evidence shows that when kids are asked to rank subjects in terms
they
of
rank English easier. There's something about English that's different for sure.
Yeah.
But it's not about it not having rules.
Right, okay. I'm not sure I'd agree with that, but okay, accept that. Okay. But in terms of the point that you're making about whether people worry simply because they're told to worry, yes, I think you're right. I mean, no one would have heard about that doctor's findings if it hadn't been splashed all over the newspaper. But then people...
No. I mean, what happened with that is an authority issue. The Lancet stupidly published a paper that they then
was picked up by
and it became a public scare, and I would suggest people didn't have an understanding of measurement and some of the quantitative issues within there, which I think is absolutely key to that I would say would be what science needs to do.
But they will never be able to make an informed decision on something like that if they've got no level of understanding of maths or risk or probability. All we're really teaching them to do is to essentially say, well, if a man in a white coat comes up to you and tells you it's okay, you take it. Is that the kind of level that is scientific literacy? I mean, how are people? I mean, most people, if you go to a hospital today and you see the doctor and he says, "Yep, you're going to have to, you need open heart surgery." Most people lie down and take the open heart surgery. They haven't got the content knowledge to make any other kind of choice. We live in a society where we rely on experts. We do. We have to rely on experts.
Well, because we've got a division of labour, and that's one of the things about modern society. But I really don't buy your argument that we shouldn't have quantity in there. Absolutely, science should be about quantity.
Of course it should be.
It should be all about quantity.
No, wait. You misunderstood what I said. I haven't said science shouldn't be about quantity. As a physicist, I believe it must be. What I'm saying is, though, if you want widespread scientific literacy, that's unachievable for the masses because they don't have that ability to buy into that quantitative. Most people can't even. Well, most
you give an example of Chinese students who are able to do it. Why can't other students do it?
No, Chinese students, example I said, in terms of misconceptions, were able to answer because they've been told certain things. That's a qualitative account. That was the qualitative account they gave us. Now, if you want to teach in a certain way, you can get more people to achieve certain things. But we've been trying to get, if you like, people to do better in maths. And I don't think the level of mathematical literacy has increased in the UK. Now, without that increase, I mean, if you say to people, you ask them, how can you have an idea about risk if you don't really understand probability? If you say to someone, well, is it going to rain tomorrow? And this is the best thing, the weather comes, there's a 45% probability of rain tomorrow. Well, is that frequency interpretation? Or what kind of interpretation is it? I don't know. I mean,
Apologies, I
no,
came very late,
yeah.
so I might have missed, I did miss the part. But just in terms of your recommendations, I picked up a slight contradiction here, so just some clarification. You said at one point, I think they need to almost rote learn a body of facts. They need a basis of content. And then you moved on to say they need understanding. And I just want you to, for me, scientific literacy is not, can't be about rote learning anything, because unless you have an understanding of it, you will never know when to draw on those those so-called isolated facts, so to speak. This was not from what was on your slide, it was
No, I'm just,
after you finished.
yeah, I just
Yeah.
want to, you see, the only thing you can actually explain to children about why two north magnets repel each other is because they do. Certainly up to a fairly advanced level, that's all we can tell them. They learn that and they can, if you like, recite that, but there's no more that they can explain or tell you about that. Nothing more.
That's not going to be what's going to be relevant in their life, is being able to sort of use a compass, know about magnetic or north, etc. I think there needs to be a level of understanding that
The compass needles point to north.
they need to know how to use it and why it is.
There's no more that you can teach them about that, other than to say that if you take the compass out, the North Pole, if you like, the north-facing point of the compass points to the North Pole.
But understanding that the Earth, in a sense, has got the poles of what we mean by them. You picked a particular example, but I'm just asking in terms of principle. You wrote learning maths times table. I can see how that can be an example. Understanding, maybe not as significant, but in terms of science as a whole, if we look at, I'm thinking biology, chemistry, physics, I would say there are very few examples where you want them just to rote learn and having no understanding. I think this is what does put kids off. I think if we taught for understanding and assess for understanding.
Right. See, that's an interesting argument, and it's an argument which is often made. But as far as I'm aware, there's no evidence to support it. It sounds like a really nice idea, doesn't it? It's a bit like context-based learning. If we teach kids things in context, it'll mean something to them. And if it means something to them, they'll be more keen to learn. But if you look at something like Salter's chemistry, which is really all about context-based learning, there's no evidence to show that it generates more chemists or they do better in that. I mean, it sounds as if it's reasonable, but I suppose for some people, different styles of learning will work. What I'm worried about, I suppose, is we have this notion of scientific literacy. It surprises me that we have no idea of what the level of scientific literacy is. I mean, what does it mean? I mean, do we think that our society is more scientific literate today than it was 10 years ago? And if so, in what sense? We make a thing about, teaching children, making sure they learn for understanding. And I suppose I would certainly very much like to know how we measure that, what we're hoping scientific literacy will show itself out as. What would we expect to see? I mean, can we think of examples where we would hope that citizens would make these kind of decisions? In terms of MMR, whatever it might be, what kind of level of engagement, of understanding, do we hope to sort of, if you like, foster amongst the overwhelming majority of our citizens?
I think that's been fairly clearly described by the PISA document that you showed. The framework for scientific literacy for this coming year is certainly a step up from how it was conceptualised for the 2006 round. And so I don't think a government's going to say, okay, we'll buy your idea, because actually we're now we're now on an international playing field. We are not. That's never going to disappear.
No, I agree. I'm not saying that the system will change. No.
And the other thing I would do is say, well, you suggest, well, this is what we should do because, and it just because this is how it is, and it brings back to me a phrase that Michael Shea once, or several times used: do we assimilate? Do we teach the kids where they are, or do we go for accelerating their learning? And by actually I'm not going through the concepts, but teaching principles of thinking so they can understand and apply and reason. Right? And there's plenty of evidence.
Well, if you look at the case and the came evidence, yes. And if you look at the amount of time that was devoted to it, yes. But we're not devoting more time to science. We've been trying lots of ways, if you like, to improve scientific literacy. Yes, we are in an international playing field, and we won't change the things. But what we're trying to do, I think, is we're not really answering the question, okay, there are the PISA figures and there's TIMS, there's all these things that we compete in. The interesting thing is, look at the countries which are at the top, and then you start looking at how many patents do those countries develop. How many Nobel Prizes do they win? And then you look at poor old America languishing on the bottom, and yet they have an enormous number of...
Well, it doesn't languish.
It doesn't.
Well, it's not at the top.
We don't do so badly on science.
Absolutely.
Well, hang on a minute. I mean, when you say we don't do badly, I mean, we're not at the top. I mean, we're sending people up to Finland all the time to see how they're teaching.
Well, Finland don't do particularly well either. So Finland aren't great. They're falling down on the PISA ranking, and they don't do very well in TIMS. So
And they're just about to change their education.
yeah.
Well, we're keen to emulate other countries.
Yes.
Why are we keen to emulate other countries? I mean, you know, if you feel that we've been successful, I mean, my presentation here today, I suppose, was to say I don't think the widespread scientific literacy is achievable. Now, if you think it is, let's have some examples of it. It'd be really interesting to hear about it.
Well, I think America's giving you
Well, hang on. Well, I'm asking for examples of, you know, people outside. I mean, do people use scientific things that they've learnt in the classroom out in their everyday lives?
But learning stuff in school isn't about using... I mean, we don't learn... I'm a maths educator. We don't learn algebra so that people go out and solve quadratic equations.
So why do we bother teaching lots of young children to do things that they will probably not need then?
Well, one of the reasons for using algebra is you learn about the structure of a number. I mean, and you learn about how you think about problems in the world in simplified ways. And I think that's what science should do. I don't think the content. I don't think magnets is important. But I do think science should be teaching measurement. Just as because
when you say teaching measurement, what do you mean by that?
To take the MMR, to have some understanding of what the probabilities mean, and I think that would be a key aim for science.
The science of the maths, probability, not the science of the maths.
There's plenty of probability in
I think the relationship between science and maths is symbiotic.
Yeah, I would think so. Certainly for someone who studied physics and got on to study physics, I'd agree with you. I mean, I think the problem, though, is that the vast majority of the population have got no desire or really inclination to understand probability, and therefore lots of science is beyond their reach.
But is that a fault with the education system, the fact that they have been taught in such a way that they've not been taught to question these things?
Well, I mean, that's a very deep philosophical question. I mean, that's a bit of the nature-nurture argument. I mean, is it the role of teachers to help people reach their potential, or do people have limitless potential, and it's the role of the teacher to take them as, you know, as high as they'll go? I don't know. That's probably very much depends on your view of education. Okay.
I don't know if these are questions or comments, but there's several of them. The one is that, so my background is very much in mathematical literacy, but not in literacy in mathematics in the sense of esoteric mathematics. More around come from a South African background. It's more around where mathematical literacy is separated from mathematics, and so it's supposed to be about application, really, real. I guess in some ways I'm sitting on exactly the same position you are, just on the other side of the divide in terms of subject or discipline, in the sense that, and one of the challenges that we face in South Africa is this notion of a mathematical gaze, that I guess mathematics teachers and mathematicians look at the world and believe we can describe the practices of the world using mathematics. Everybody else who lives in the world knows that they can do it differently. So, and they do differently on a daily basis. And it's almost as though then if you, from a mathematician's perspective, if you can't engage mathematically, you're not successful. And yet people do it all the time successfully. So, I mean, there is, I think, for me, part of what you're saying is around that issue. It's around the extent to which, as scientists, we evaluate, you evaluate the world and then make decisions about what we think people should know, as opposed to what people can actually do on their own. But there's also an issue, a question for me around the notion of social capital here. So we live in a society where, whether this is accurate or not, mathematics and science are benchmarks, and that by participating in those disciplines, supposedly it provides you with the degree of social capital in terms of economic status, in terms of career objective, etc. So I guess part of my query is to what extent is it necessary to play that game to popularize mathematics and science, mathematical literacy and science, so that we try and provide some sort of access? Or to what extent do we just recognize that these are unattainable for large majorities of students, and we just accept that as a status quo?
Yeah, I mean, I think we're coming at things from probably the same perspective in a way. I mean, most people live their lives with lots and lots of misconceptions in science, but they do live their lives very well. I suppose in a way we're seeing much the same sort of thing in terms of, you know, the idea of increasing the number of people going into undergraduate courses. You know, we've increased the number from 5, 15, 25, we're up at 40-something% of people are going to university, because we recognise that having an undergraduate degree can increase your lifetime earning. You know, lots of good things about it. But as more people do it, that measure becomes less useful, because graduate salaries decrease as more people achieve them. Now, I think I would be saying that the last point that you made would be more where I think we do. I don't want people not to study physics. I don't want, and I think we should be encouraging people to go as far as they can. But we have to recognise that in many ways, the idea of scientific literacy as it is now can't be achieved. I don't think that you can engage with lots of the ideas about to be functionally scientifically literate if you don't have an understanding of the basic concepts. Without that, you can talk, but there's not going to be anything there for you to actually use.
Are there underlying processes that, so instead of focusing on specific content, are there underlying processes that around how we want people to think and act and behave as scientifically literate? So for me, to be mathematically literate is about being able to model a situation if you want to. Whether or not you understand the mathematics is irrelevant, because you can use the internet to learn the mathematics. But it's about having the capacity to put that into practice in order to make sense of the situation.
There is. I mean, people talk about the scientific process. You know, that's well looked into. The question, of course, is that achievable? So we were talking just before people came in about what sort of things would you expect people to be able to do if they used scientific process. So it might be that they could collect some data, they would know how to process it. But again, that isn't something that many people find easy. And I just worry that if we say that scientific literacy is all about mastering that process, we cut off a lot of people from ever achieving it then. One of the things we were talking about, I mean, with undergraduates, I did some work on the MA program. We had people who had backgrounds in A-level maths, some had no maths, some had physics. And I used to find it interesting to give them problems where you would think, well, surely if they thought in a particular way, you know, we say that if you study physics, you're going to be a more rational person, you're going to be able to think about things. You've probably heard of the Monty Hall door problem and things like that. No difference in the way scientists or non-scientists oppose that problem at all. And so when we start saying, well, there is a scientific way of doing things, often, you know, I think scientists probably take longer as they ponder things because they're weighing up the information they got. Whereas most people, given a novel situation, just think by drawing on analogies. And that's the example, with the case with, hotter and colder in the summer. Yeah, I mean, if you think teaching process is going to be what you feel someone who is scientifically or mathematically literate could do, I suppose it'd be interesting to look and see how effective that is.
I was just, sorry, I'm not mentioning that MMR would
MMR, right, yeah.
That for me, I would have looked at that and said, perhaps what we need is people who have the capacity to go onto the internet, read something about it, make sense of the information, and then make an informed decision. Whether it's technical or not, whether it involves probability or not, that there's a capacity to engage at a very simplistic level with the arguments that we present.
Yeah, I would agree with that. But the question, the only caveat is, I say, that the level that would have to be to allow people to actually engage with it becomes very, very low.
Okay.
Yeah, I would agree with that 100%. Yeah.
Yeah, thank you.
So the vaccination thing hasn't gone away. It's still happening in the United States, where in rich areas of California they have lower vaccination rates than very poor areas in Africa, because these wealthy parents just worry about what they've read on the internet, and the fact it's all being disproved, but perhaps on the internet must be true. So there is this persistent problem, and I think part of it is the one aspect of scientific literacy. It'd be nice if you could do the process of science. Yeah. I agree with you that may be hard. In order to enjoy music, I'm sure it's much better if you learn how to play the violin. But it's not actually essential. It's just, I'm sure you enjoy music better than me because you can play the violin. But I can still enjoy a nice tune. Yeah. So, I would claim one aspect of scientific literacy is to help people understand what the scientific process as done by scientists is. Because there's an awful lot of major misconceptions around that, in that it's like we find true facts and we're always right. It's just we get more right stuff. And then it becomes deeply confusing when scientists disagree, because you were never taught that.
You weren't taught in science.
Yeah. And that just means, obviously it's just a matter of opinion, it's what you feel like, so therefore science is bogus. And those kinds of misconceptions, you see that in the whole, climate science.
Yeah, there's something like that, I would think, is realistically achievable. Learning that scientists do make mistakes, most theories which have been proposed have actually been falsified. Yeah, things like that can. But I think that comes to the point that you were making about when you're looking about something and you say, if you go to the internet, if you want people to make some kind of decision, then the level at which that information is presented, if it's too high, they can't engage with it. And then you realise that in order for most people who are just going on it, who don't have a realistically deep scientific understanding, it's going to be a very superficial level. And that isn't always going to make for a good decision.
But I think I agree with you, there's a general distrust of science among affluent society. It's just like we've been hoodwinked, the scientists are just,
I think it's the terminology we use as well. I think things like scientific theory, like you pointed out, because it's a theory, it means that there is no proof. It's just an idea that we've come up with. And I think if a lot of people actually understood, well, actually gravity is a theory, and a lot of other things that we use are theories, then they wouldn't get so caught up in this idea that we don't really know what we're on about.
So shouldn't we be saying that understanding the nature of science, including all the scientific processes, I disagree that it's not understandable. I think it's very understandable. I think if it's taught correctly, and that includes what theory means, understanding how theories develop, the difference between a theory and a law, for example. I think this is easily understandable.
That's moving towards a very, what I've called a qualitative understanding of science, isn't it?
I don't disagree with that.
Well, that's what I'm saying. I'm thinking if you're presenting something which is simply saying that really what we want people is to be able to, have a qualitative, descriptive account, well, yeah, that would be fine.
But it's the understanding of it that I think is fundamental. You can't just learn that a theory is X, Y, and Z. You've got to do science. You've got to come into the classroom and see yourself as doing science, and that means making mistakes and not being told you haven't got the right answer. scientists don't get right answers. There's an explanation for
Well,
the
no, we have to be careful there, don't we? Because doing science in school is not doing science as a scientist. Doing science in school, there is a right answer, and
No, I disagree.
well, part of what you're doing in science is surely to become part of, or to take on the knowledge which has been gained before you as well. I mean, if we were, you know, if you had a class and you're hoping that they'll discover Newton's laws of motion, you'd probably be waiting. No.
In every topic, you can set a question that by the end of the lesson, we're hoping they'll be able to answer. And the inquiry, there should be inquiring and through.
Well, there's no evidence to show that inquiry-based learning is any more effective than straight didactic teaching.
It depends on how you measure it.
Well, yeah, but I mean, I think we have to be careful making sort of claims that certain ways of teaching are more effective. You know, inquiry-based will. I think we have to say, okay, what's the evidence that it will, in what situations, and what we want to achieve? Because otherwise, what we're really doing is we're saying that, well, I mean, I believe that the biggest factor which impacts on teaching is the teacher. I think if you have a great teacher and they teach in an old traditional didactic manner, they could probably be more effective than a poor teacher who sets out every time to do something inquiry-based, which doesn't seem to get very far. So I'm not very keen on thinking that there is one type of approach which will be more effective than another consistently.
No, I don't think any, but I do think we shouldn't be seeing it as a body of knowledge that we're there to transmit it. I think they've got to feel like they are doing science when they come in and get that sense of excitement, because only in that way are they going to feel.
Well, no, I disagree. I mean, my own work has shown clearly that lots of kids will really enjoy the sense of excitement of doing practical work, and those who enjoy it most are those who are most adamant they don't want to pursue it. I don't think we can see the sense of excitement as being a measure of success in science teaching.
It depends what you think success is.
Well,
I mean, I would just suggest that there might be something to borrow from evidence-based medicine.
Yeah, probably.
Because in the teaching, that's my background. In the teaching of evidence-based medicine, to follow on from what you said, what you're trying to do is use that body of knowledge that exists in terms of cases, and the case becomes the problem, if you like. And then you can actually take a group within the class, in this case, or the mind programs, and you actually assign them specific tasks to work on, either using the modelling that you learned in Maastricht or Roskilde universities or whatever. And then you can get a form of inquiry-based learning based upon strong cases, which allow medical students to actually look at the difference between, dare I say, evidence-based approaches, where the old style of teaching medicine, you do like this because I'm a professor, versus, well, what does the science say, and how do you differentiate between, if you like, the experimental versus the qualitative, or the observational science, I should say, in medicine. So there's lots of ways of drawing that together. And I was just thinking of something you said, Mary, which is about the thinking and reasoning. You can't actually do evidence-based medicine or use problem-based learning as I briefly described without spending a lot of time on that aspect, the thinking and reasoning component, which, because this is all new to me, and I do apologise, I'm just sat here not really knowing in the background, I'm thinking, well, what you really described is critical thinking and reasoning applied to science. What you described, and I thought really nicely, as a gaze, and that's all this really might be. So is that a way of possibly tying something together? I don't know.
Yeah, I think lots of the things, as you say, depend on the perspective you're coming from. And as you say, seeing things and tying them together. I mean, I'm very much in favour of trying to achieve a widespread scientific literacy. But to do that, I suppose I'm saying we have to be realistic about what's achievable. And I think all I'm saying is that the higher the level of scientific literacy, the more conceptual understanding you need in order to be able to do, as you said, to go online, to find something, to be able to make a decision, and for that decision to be, if you like, rational, and to be able to, as well, to be able to work out what the...
Because what you described there was effectively the Maastricht model of inquiry-based learning. where people get a role within the group. They then have a presentation to produce. But fundamentally, if you don't know what a word means, somebody needs to go and find it. And somebody needs to find evidence for.
One last, do you want?
Yeah, carry on. There's what, I see the lights are going out.
Yes.
Because you mentioned the Galileo experiment, and I am a Chinese physics teacher in secondary school, high school. I think in school we really teach a lot of maths in physics class. Every Chinese student who learn physics, they all think if you want to do well in physics, you must be very well in maths. And I'm thinking that why they remember the conclusion so well, that is because we really told them something more difficult in physics class. And children cannot remember all the things teacher told them. So they must have forgotten something, so they just remember the most easy things. And so I have a little concern that if I raise my expectation for my students to A, and maybe they can only achieve B. So if you lower your expectations for them, for example, to B, will it be possible that they can only achieve C?
Well, it's a bit like universities at the moment have started making lots more unconditional offers. And the worry is, of course, that if you make more unconditional offers early on, the students will sit back in school and say, well, I don't need to worry now. I've been given my unconditional offer, I can get into Nottingham and it's brilliant. I don't know. I'm not sure what the evidence is for that. I mean, what I'm saying is it seems to me anyway that the notion, if we want meaningful scientific literacy, we want to be asking ourselves, how would that manifest itself in society? What would it mean to say that if you stopped someone in a shop and you wanted to know, you stopped someone outside on the street and you want to know if they're scientifically literate, what sort of things would you ask them or expect them to be able to do so that you could say this is a scientifically literate member of society? Now, if you don't know the answer to that, then it seems that the whole notion of scientific literacy is very woolly. It's got no substance to it. And I'm simply thinking, well, if it's something that we want everyone to be, it's widespread, then we have to be very clear about what we want them to do. And if we set that goal too high, were we to ask the people in the street, no, very few people would achieve it.
Hang on, no,
Okay,
wait. Ian, you give me a question.